Yeah, so hi everyone, I'm Ben, I'm Anthony's student, I'm not even a student anymore, I'm a postdoc, and yeah, it's nice to be here in St. Martin's so I can tell you all about Ubiq. So I'm Ubiq's developer, so I kind of mostly work on the tech side of Ubiq, which is what I'll talk about here.
Go back there.
Oh. Okay, so if we're lucky, we're going to do a live demonstration here. We will see how that goes. I've got presented you. Right, so yeah, Phoenix, would you mind trying to get in VR and join us there? So what this is our kind of like our WebXR interface. That's what you'll reach if you go to this web address, and you can kind of join us in Ubiq and try it out. So it's it's an application that it's our demo scene, but it's kind of built for WebXR.
Try that one more already.
Okay. Cool. So Phoenix is currently he's wearing the headset. You can visit a web address kind of on the headset, and then you can click the enter XR button, and so there it is, and then you're in a kind of XR session. So it's all really easy to kind of connect up. And that's the meat of the system. The idea is let's make it as easy as possible for people to get into XR. Cool. Thank you, Phoenix. You can leave now. Okay, so how Ubiq fits together, it's primarily a Unity package, which you can kind of download from GitHub. The entire thing is 100% open source, and that contains a bunch of samples, like the sample that you just saw running, which is that kind of like that, WebXR sample. And then we also include a bunch of other things, kind of like live documentation, which you can kind of try out and immediately see things changing. And then we've got kind of a server component, which is sort of fairly small, fairly lightweight. It runs on Node, and that also includes a bunch of samples for doing things like kind of scalability, scaling differently, that sort of thing. And then we've got kind of online documentation if you prefer to read, and a bunch of example projects from our kind of previous students trying to do different interesting things with Ubiq. So we try and support kind of lots of different. We try and support lots of different platforms with Ubiq. So it's built through. Yeah, I know. Okay, maybe it's the. Let's see how it goes. Yeah, so it's built through. It's built as primarily a Unity package, which means that you can target lots of different kind of platforms for your built applications. And then we've made all of Ubiq's features like VoIP and all the different avatar stuff and connectivity. We've made that all work. This is not so good. I'll just try connecting through this USB-C thing. That is just a piercing sound. Okay, yeah, so hopefully this stays stable this time. So yes, Unity allows us to target lots of different platforms, and then we've tried to make all of kind of Ubiq's core features, like VoIP and so on, work across these different platforms, like on the web and that kind of thing. So you can also make built applications for the various platforms, for like kind of standalone headsets and desktop platforms and everything like that. Yeah, I don't have any other ports to try. It would better if it's not full screen. Yeah, let's try that then. Okay, yeah. So why are we so interested in WebXR? Well, because it allows us to be cross-platform and to kind of interact with different devices without having to build multiple applications. So for researchers, this is also particularly useful because you can deploy to participant headsets without them needing to have developer access, that kind of thing. So if you wanted to run like a remote experiment, as we did during lockdown, during COVID lockdowns, you can do that without needing your participants to be developers or to have developer accounts, which is a big kind of time saver for us. So here's a little demo of connecting to a WebXR session in the browser. So you've got like a kind of, this is on a meta quest, you've got the pass-through, and then you can load up Ubiq and you can kind of drag it around just with hand tracking and then enter an XR session. And it all works pretty easily. And you can also reach difficult to otherwise reach platforms like the Vision Pro, which otherwise needs things like a Unity Pro license and kind of like a Mac device to develop on. So what does Ubiq have in its core features? We've got kind of an avatar system, we've got VoIP, we've got this room system that Anthony's mentioned, we've got distributed logging and network supporting. So I'll just go through them all really quickly with some examples. So for our avatar system, on the left there we've got the kind of the basic Ubiq avatar, which is CC0 and kind of works everywhere, so it's kind of really easy. And then on the right we've got what were they called? Well, Rocketbox avatars. So what we've got for them is a kind of motion matching based animation system. So that's fairly experimental, but it does actually allow you to control the full body without needing things like kind of like that kind of thing, which is another way of controlling full body avatars. What this actually composes is that the system will spawn an avatar for you, it will handle changing avatars, and it will handle kind of networking the position of that avatar and hand tracking joint positions and that kind of stuff. Next we got VoIP, so that's peer-to-peer using WebRTC. The reason for that is that basically it works in the browser, it's handled on a hardware level in the browser, which is quite useful, and then benefits from other kind of WebRTC advantages like end-to-end encryption and kind of codecs like Opus. Yes, because it's peer-to-peer, it keeps your kind of hosting costs relatively low. It keeps the server complexity a bit lower too. Then we got the room system. So this allows us to have one server process which manages multiple rooms. So the kind of like the actual architecture here, actually having a server in the mix is quite useful because it allows us to do various networking tasks which can resolve race conditions. If you have a purely peer-to-peer network, you can struggle with things like kind of working out who's the authority on various different things. and the server helps to resolve that in a kind of relatively easy way. And you can join rooms by like a kind of long computer readable GUID or by human readable join code, and that's kind of disableable too if you want the rooms to be a bit more private. We have a distributed logging system, so what this basically means is logs are created and they kind of move around the network and they can be consumed at any point in the network. So you can have the server consume the logs, or you can have one peer consume the logs. The idea behind that is that you might have a situation where one peer is actually the experimenter and might want all the logs and might not want the participants to consume them, and so that's what that system is designed for. And then we have our spawning system. So the idea behind this system is that you spawn with a particular scope. So you might spawn with a peer scope, objects that kind of belong to a peer in particular. Things like the peer's avatar is spawned with peer scope, and that way they're kind of naturally cleaned up when the peer leaves the room, or when you leave the room the other peers are in, their avatars get cleaned up. And then just a kind of fun example of some spawning. And you can also spawn with room scope, which means that objects will persist as long as the room does. Rooms in kind of Ubiq parlance, they exist on the server for as long as there is somebody using them. So when all the peers leave a room, that room will be cleaned up, the server will kind of return to its kind of default state, and you don't need to worry about managing the memory anymore. Okay, and so learning Ubiq, as I mentioned before, we've got this kind of, we've got the demo scene, which is what you can see running in the browser. And so because every component of that is open source, you can just load up that scene and just click play, and you will be connected. You'll be connected to our server in the UK, but it's relatively easy to host your own. And then we've got these kind of live examples. So the spawning thing that you just saw was one of those live examples, and that allows you to see each kind of feature of Ubiq in like a minimal way, so that you can kind of understand what code actually does exactly what. And then if you prefer to read, we've got those docs online. So as far as actually making stuff with Ubiq, extending Ubiq's core functionality, we've got a few different kind of networking primitives that you can use. So let's go through those extremely quickly. You've got messaging, which is how you send kind of quick one-shot messages. So for example, avatar positions are a good example of what you might do with messaging. So the concept here is that everyone who might receive a message registers themselves to the network with a particular ID, and then you can send a message tagged with that ID. Everyone on the receiving end who is registered with that ID will receive it. So for example, you have your avatar, they have a particular ID. Other versions of your avatar across the network will have the same ID, and they'll receive the position updates. The kind of like the disadvantage, and I suppose also advantage of that kind of networking primitive, is that if people aren't in the room, it's not stored, right? It's sent once and then it's gone. So it's useful for things like positions, or poses just in general, which will kind of disappear or not be relevant later on. And then for networking things which will be relevant later on, we have this idea of properties. So they are synced dictionaries. They live on the server, and when a new peer joins, they will actually send every other peer's properties and also the room's properties. So the kind of benefit of this is that, first of all, for a room property, the server handles collisions for you, so that everybody, regardless of whether they are when they joined, and also even if everybody writes the same property, they will end up with the same value. But then also, peers who join later will receive those same properties. So in this case, you've got these properties being set, and if the peer is in the same room, so if peer 2 is in the same room, they will get the properties from peer 1, and if they're out of the room, they won't. But if they join later, they'll also get those properties. And then the last one, really simple, is blogs. So these are kind of intended to be large chunks of data, which any peer can write to the server. They'll live alongside a room, and when that room is gone, the blobs will also be cleaned up. They don't get automatically synced, so they're suitable for storing kind of large amounts of info, and then peers can kind of request them. Okay, so things we've been working on recently. We now have full WebXR support for all our features, and we also recently added out-of-the-box support for hand tracking, which you can use on kind of various different avatars. So the Ready Player Me avatars that we have packaged as a Ubiq sample, they support that hand tracking kind of out of the box, including on WebXR. And for the future, so we've been recently spending a lot of time on our experimental motion matching based kind of XR full body animation. So the way that works is based on a research paper and also on help from a PhD student called Jose Luis Ponton, I believe his name is, who helped us out greatly with this kind of concept. So the upper body is fully IEEE animated, and the lower body is fully animated with motion matching, and we merge them together, and it works quite nicely. You'll see a small example of that later on. And then we want to work on a kind of documentation overhaul. We've got the good live examples, but our previous documentation is kind of based on what we've done for the students over the past sort of like maybe 3 or 4 years, and we want to kind of bring that all together and make it kind of accessible. And we're also thinking, how can we kind of expand that room model to things that survive beyond the room, and we want to make that kind of we want to make an interface to that that's really easy to use, hopefully like the rest of Ubiq is. And finally, we have a kind of an admin panel that's accessible through the browser, and you can do things like set properties in that and kind of control and experiment through that. But it's not very obvious how to reach it, and we want to kind of add more features where you can kind of really monitor the experiment and see exactly what's going on, like visualizing logs. So that's a summary of Ubiq. It's a Unity package, and it's primarily a message passing library. We have a few different networking primitives. It targets use cases excluded by common monetization methods. So other kind of packages that might do this, or other kind of social XR toolkits, are built for particular reasons, and we felt like there was this gap for things to be used for research and teaching, things that were really hackable. Okay, so some of the PhD students from our group will come and show some example projects, if you guys are ready. Yeah. Should I go first?
So, good morning everyone, my name is Felix. I'm the first year PhD student in the exams with IEEE group. under Anthony's supervision. So today I'm going to present one of the ongoing projects of ours. It's called Accomplice VR. The idea stands from like an existing poster that was like published by Anthony 1 year ago. And so Accomplice VR itself is, you can imagine that as a panoramic streaming and co-piloting tool for individual gamers in the VR scenario. So there's a very simple system diagram and some key details about it. So Accomplice VR will be an application for two users. One is the pilot and one is the co-pilot. The pilot is running the VR games or applications in individual modes, and through Ubiq extensions, you're gonna able to see the co-pilots like working or playing the games with you. And on the co-pilot side, the co-pilot can be running the application on any of the devices, including VR HMDs or monitors from PC or mobile. And the co-pilot can serve as guidance or just friends watching the pilot's playing process together with the gamers. And here is like a very brief system diagram of the system. So basically, we're utilizing the Steam VR overlay as a way to allow Ubiq to be inserted into individual gameplays in like any of the VR games or applications. And the co-pilot is supported through Ubiq, so we have all the features Ben has mentioned, and also like any of the extensions, like if we want to add onto the Ubiq. And how does it look? It's a very simple example through like the pilot's playing Skyrim VR, which is a RPG VR game, and the co-pilot is watching the whole process happening on a modern PC. And yeah, you can see that we can see the little Ubiq avatars appearing inside of the game, serving as a guide for the player himself. And for the co-pilot, he can track the very real-time streaming in a quotation mark panoramic scene, and with like relatively high refresh rate as well as the visual quality. So what can it do? Accomplice VR can be used for a lot of potential usage, including co-piloting tool for in-game guidance in single-player games, or it can be served as a novel way of streaming between friends and players, comparing with other state-of-the-art VR streaming papers, research, and tools. Accomplice VR is more is lower in its computational requirements, and as well as it's being very real-time asymmetrics. You can use it on any of the platforms, and it is an extended paradigm for social VR interactions because, in a certain way, it takes the idea of discords, and we're trying to enable two of the friends or even more people to play together in a single-player games. So that will be an extended usage for social VR, and it is also a way to enable non-VR users to enable interactions between non-VR users and VR users. And there will be a very short, around 2 minutes, demo videos for the Accomplice VR, so you can see how it is in this applications view. And I will just check for the video very quickly. Sorry about the waiting. Sorry, there it is.
Sorry. So it seems like you share the same position but not the same viewpoint.
I'm sorry?
It's not clear about how you share the viewpoints between the co-pilot and the pilot.
Yeah.
You are in the same place, but you can, each one can look what he wants.
Yeah, I think you can imagine the Compass VR as a world, as a Ubiq world, but the pilot is streaming what he sees in the SteamVR compatible apps like in the same time. So they're actually like interacting inside of Ubiq. So
okay.
Yeah, so they're actually in the same world, but not in the world in the game.
Okay. So you follow the pilot. As a co-pilot, you follow the pilot. If the pilot moves.
Yeah, I can see the pilots moving. It's all synchronized through Ubiq. And for the co-pilot, he only sees like what's happening in the game and a co-pilot avatar. Or maybe in the future works we'll add more ways to interact, maybe laser pens or like obstacles, tools, boundary elements, anything you can imagine. Yep. So that is about a Compass VR. I'm finished. Jimmy, please go. Thank you very much.
As you point out, it works in pretty much everything you've tried in SteamVR?
Yeah, it's working with any of the SteamVR compatible apps. Any.
Because it's using built-in functionality of SteamVR that allows you to effectively combine AR apps into VR apps. So you can do it in Job Simulator or do it. And yes, we've been experimenting, to your question, we've been experimenting with how the other person should see it. Should it be panoramas that move? Should it be you slave the viewpoint? But if the slave viewpoint seems to be acceptable if it's a phone, but if they've got a headset on, you need to decouple so you see effectively a sort of panorama around you and you're not
So hello everyone, my name is Jingyi and I'm from University College London and I'm a second year PhD student under supervision of Professor Anthony Steed. I didn't click anything, I'm not sure why, it goes to the next page. Today I'm going to demonstrate two demos. They are all published work and one of them is actually one of the work that I published in this year, IEEE VR, so feel free to join us on Wednesday. And so let's get started. So the first demo is a single actor controlling multiple avatars for social virtual realities. So social virtual reality has gained popularity in various fields, including entertainment, training, and also for psychological researchers. A key element of social virtual reality is facilitating social interactions between users and multiple virtual humans. So despite the advances in crowd generation and AI agents, existing technology still falls short of creating a virtual human that responds naturally in open-ended scenarios where users have full freedom in interactions. While the technology might be advancement and may eventually enable the creation of realistic virtual humans capable of natural interactions in VR, human intervention remains essential for directing the narratives, enhancing the credibility of the experience, and managing unforeseen situations. So in such cases, rather than adding new virtual humans to the scene, we believe it can be more practical for an actor to take control of a virtual human already present in the environment. So we build a system that enables a single actor to control and embody multiple virtual humans. The virtual human are, there's two phases. The first one is when the user are interacting with the virtual human shown over here. An actor will take control of that virtual human. And the another phase is the non-interactive phases where the user is not interacting with that character. So it will be taken over. It will be playing pre-recorded motions. Our system supports full body avatar with 6-point tracking, and we have a voice modulator. Again, I haven't clicked anything. I'm not sure why. It's going to next slides. So we introduce a voice modulator that adapts the actor's voice to match unique voices of different virtual humans. So on the left is what the users see, so they can view multiple virtual humans in the scene. So for here you can see 2 of them. And on the right is what the actor sees. So when interacting with the user, the actor take control of a selected virtual human and following the rule and scripts of that character. And when it is not interacting with any virtual human in non-interactive phases, they have a map panel which shows all the available virtual human to be takeover, and they can click on it to jump to that position and take over that avatar. So the potential usage of the system is the same as the social VR example that we mentioned before. So for example, in VR shows and theater, we can only have 1 or few actors to save labors. And for training purposes, we can have students or patients being taken over by a senior lecturer or a teacher or doctor to train for a more junior teacher or doctor, and also for psychological researchers. So I'm going to play a short video to demonstrate a virtual museum scenario where the user will play as an intern on their first day of working, and the actor will jump among 5 distinct virtual characters, which are their supervisor and their colleagues and also the museum visitors. So there we are.
Hello.
Hey, welcome to your first day.
Thank you.
I'm the supervisor here at the museum. My name is Lisa.
So to save time, we didn't show the full scenario.
I just wanted to know what is your overall experience of our exhibition?
Okay, I like the exhibit. The arrangement is good and they've got quite a nice atmosphere.
Today, I'm working here at the museum, and I would like to ask you what was your overall experience of our exhibition. Did you enjoy it?
With this tip, well, it's not fascinating, but a bit overall. Maybe some guided towards some descriptions will help.
So you can see while the participants or the users moving.
Ask you, how do you enjoy the museum? I'm working here. I would like to have the customer point of view.
Sorry, I prefer not to comment. Yeah, sorry.
It's alright. Thank you. Have a great day.
Hey, very nice to meet you. I am Jack.
Hi, nice to meet you. I just started today.
Okay, so that's a very short demonstration. I'm not sure if you can tell. Actually, all of the characters are controlled by me, and so yeah. Okay, so the next one, the Houston Arc, a mixed reality approach to cultural heritage tool. This is also a paper published in workshop paper published in ISMA. And so, right across our office, there is an arc called Victorian Houston. There is a station called Victorian Houston Station that once has a grand gateway. The Houston Arc looks like this one. However, in 1962, in the face of widespread public opposition, the arch has been demolished during the station's reconstruction. So we want to revive its history and using technology. Augmented reality and virtual reality are all widely used in cultural heritage exploration. Each device has distinct strengths, and combining them might open new potential and opportunities for immersive experiences. So AR user can receive real-time contextual information as they physically present at the site, and AR also has the potential to be used outdoor. VR users are not limited by the location, so they can have this freedom to navigate around the space without physical constraints. So we built a system that we built an outdoor AR/VR collaboration system using Google Geospatial and Cesium and also Ubiq. So the AR user is physically located somewhere in the world, while the VR user enters a virtual replica of the AR user's surroundings. So this allowed both users to experience the same environment, one in reality and the other in the virtual space. So for this demo, the AR user was on site holding an Android phone, as you can see over here, and the VR user were joined remotely using a MetaQuest Pro headset. So with the Ubiq library, the system enables real-time interaction through virtual avatars that allows users to hear and see each other. So we enabled shared virtual objects, including images, videos, and 3D models. Also, object spawning that is bringing additional objects into the world is available. 3D pen to draw any 3D paintings or something to enhance collaboration. Also, there's a video streaming, so that means a live video streaming from the AR user's perspective. This gives a VR user better awareness of what's going on around the AR user. So you can see it's shown on the left side. So I'm also going to play a short video to demonstrate this. We wish to use this example to showcase the cross-platform collaboration capability of the Ubiq library.
Why am I sitting here at my Houston station? Why do I feel like there was an arc? I wish I could know more.
It's hard to learn the secrets and history of places you pass by in daily life. The sport is either too niche or the information online is hard to find and lack concrete details. Why don't we hire a VR local guide? This demo utilizes the example of a virtual tour guide to demonstrate the potential of using an outdoor mobile AR system as a bridge to extend VR users' view, reaching to the larger physical world. We aim to enhance interactions between AR and VR in both physical and virtual world. Let's start from the Houston Arc.
Alright.
With the help of the Ubiq networking library, users can join the same room and view each other's location, position, and gesture. Networked objects can be shared among the peers in the virtual room, and object spawning enables users to bring additional objects from Perfect into the scene. Select image and put this one over here and the layout over here. Nice. So I'm going to
blueprint. Okay.
going to show you a video as well. So I just put it here. And yeah, you can see this one is the old Houston station video. If you can come closer to the arc. Here's something interesting actually, and let's draw an arc. I'll go first. Feel free to add anything if you want to. So, what do you think?
Wow, it's so realistic.
So that's the two demos that I want to show today, and I hope you enjoy. And I'll pass back to Ben, I guess.
Do you have the hardware?
Yes,
That would minimize switching.
Okay, sure. So I'll continue. And so the next session is about about Ubiq library. So I'll start first with how do I build an NPC using ChatGPT.
we did prepare this one in advance, but somebody has asked that on Discord. So,